Hi, we have the AP Physics 1 past paper 2019. There is a section free response question. We have the question number 2 which carry the 12 point. In this problem, we explore how the relative mass of two blocks affect the acceleration of the blocks. Now there is a two block system as shown in a fig. There is a block A which is have the mass ma rest on a tabletop. There is a negligible friction between the block and the tabletop. Block B is hanging from the thin string which has attached with the pulley with the block A. Now, the pulley has a negligible friction and the spin with negligible friction, though about its axle, both blocks released from the rest. Okay. Now, the question is if the block of the mass M is much greater than compared to mass of the block B. Estimate the magnitude of acceleration of the block after release. Explain your reasoning without driving or using the equation. In this scenario, the block of the mass is much greater as compared to the B. So B, the answer is acceleration of the block is very small, close to the zero. Now answer is this because the driving force, the pulling force is the block mass MBG. So MBG has to pull the whole system. That whole system carry the both mass MA and MB. So because block of mass M is very massive, it has a lot of inertia. So MA is very greater than MB. So if that very tiny force or small force trying to a very large mass resulting with the very small acceleration, that's the reason I have to say the acceleration is close to the zero or very small value. Now, if the scenario change, if the block of mass M is very less than the block of mass B, estimate the magnitude of acceleration after release. Explore your reasoning without driving or using the equation. Now, the answer is acceleration of the block is close to the G, is almost G. Why? The block B is heavier, that's the driving force. So the gravity pulls very strongly. Mass block A is very light on a tabletop. It is easy to drag along. It seems the block B falls almost as nothing is holding it back to pulling block A with it, making the whole system accelerate nearly to the G. Almost free fall condition is there. So that's the answer. Now the next situation. Now suppose neither block mass M is greater than the other. Both are not necessarily to the equal. The dot represents the block A, block B indicated by the label on each dot, draw and label forces, not the component exerted on a block after release. Represent each force by the distinct arrow starting on and pointing away from the dot. Now the block is on the tabletop. There is the two forces vertically. One is the gravitational force that is acting on downward. You can say it's a weight. Other is the normal of the table that is upward. Both forces are opposite. The only horizontal force is the tension through the string, and that block B is hanging. So there are only two forces, one from the weight and other from the tension from the string. So as seen from the dot, there are the arrowheads labeling the direction of the forces acting on a two masses. Now, the equation of the acceleration of the block after release in term of ma, mb, and the physical constant which is appropriate. If you need to draw anything that you have to show on part B to assist your solution, now use the space below. Don't add anything to the figure in the part B. Okay. The block A on the tabletop, there is no vertical motion. That means there is no net force acting on it. Mean both forces acting on vertically have equal magnitude but opposite in direction. That's why they are cancelling each effect. There is no vertical motion due to this. There is only net force horizontal, that's towards the pulley, that is the tension. So net force acting on A is tension. Ma is equal to T. For the block B, there is a net force downward because weight is larger than the tension causing the accelerate downward. So MA is the net force acting on a B. So mg minus T. We have the value of T. We can place this value of T from here. We can place MBA is equal to MBG minus MAA. So both have the A common. We can negative factor move to there, become the positive. We can take the common A value of the A is equal to MBG divided by MB plus MA. The upper factor denominator is representing the net force, and the MB plus MA represent the total mass of the system. Now consider the scenario from the part A2 where the mass MB is much less than the mass block B. Does your equation accelerate of the blocks from part C agree with your reasoning? Answer is with yes or no. Briefly explain the reasoning. Okay, answer is yes. It is consistent with our part B. Reasoning is there the net equation A is equal to MBG over MB plus MA if we neglect MA because MB is very greater than as compared to MA. So the equation can be represent MB should be cancelled with MB is approximately equal to G. So equation agree with the reasoning where acceleration is almost equal to free fall G. Now the next part, while the blocks are accelerating, tension in vertical portion of the string is T1. Next pulley's negligible mass has replaced with the second pulley with mass is not negligible. When the blocks are accelerating in this scenario, tension in vertical portion is string T2. How the two tensions compare to each other? T2 is greater than T1, T2 is equal to T1, T2 is less than T1. Explain your reasoning. The answer is T2 is greater than T1. Now the second case when the pulley has the significant mass, so tension in a rope or string would be greater than as compared to previous case. Why? Because the massive pulley have the rotational inertia, means some of the gravitational energy should go into the rotating the pulley. So block B must have the smaller net force as to have the smaller acceleration. So if the net force is smaller, then whole factor should be less. To become less, we have to increase the T because it has the negative sign. So if the tension is increased, so net force should be decreased. The rope tension must be larger as compared to the previous case. So that's the answer. If you have any query, kindly ask in the comments. If you like the content, kindly subscribe and share with your friends. Okay, take care.